Modern vehicles manufactured after 2020 feature sophisticated rear light failure warning systems that have revolutionized how we detect and diagnose lighting problems. These systems use LED arrays with individual bulb monitoring, CAN bus integration for precise diagnostics, OBD3 compatibility, and advanced diagnostic capabilities that far exceed older vehicles. The most common warning types include brake light failure alerts, turn signal malfunctions, tail light circuit errors, LED array partial failures, and trailer light connection errors. The system works through a network of components. Bulb monitoring modules detect changes in electrical resistance. The body control module processes these signals through the CAN bus network, and dashboard warnings are triggered automatically with specific diagnostic trouble codes. The primary causes of rear light warnings break down as follows. Actual bulb failure accounts for 40% of cases, faulty wiring or connections 25%, failed light control modules 15%, incorrect bulb types 10%, and software glitches 10%. You can diagnose rear light issues without a scanner using several methods: visual inspection of all lights, bulb testing with a multimeter, socket inspection for corrosion, fuse verification, and ground connection checks. With a diagnostic scanner, the process becomes more precise. Connect via the OBD2 port, retrieve specific diagnostic trouble codes, monitor live circuit data, test components using actuator functions, and clear codes after completing repairs. Understanding your vehicle's fuse box layout is crucial for effective diagnosis. Always check the relevant lighting fuses as part of your troubleshooting process, as blown fuses are often the simplest cause of rear light warnings. There are two main approaches to fixing rear light failure warnings. You can diagnose the problem manually without special equipment, or use a diagnostic scanner for more precise troubleshooting. The manual method starts with a thorough visual inspection. Turn on your engine and activate all rear lights, including brake lights, turn signals, and hazard lights, to identify which specific bulb has failed. Next, remove the suspected failed bulbs and test them using a multimeter. Set the multimeter to continuity mode and check if the bulb filament is intact. A good bulb will show continuity, while a blown bulb will show no connection. Examine the light sockets for corrosion, which appears as white or green buildup on the contacts. Corroded sockets can cause intermittent failures and false warnings. Clean the contacts with electrical contact cleaner and ensure tight connections. Check the fuse box for blown fuses related to rear lighting circuits. Also verify that ground connections are clean and tight, as poor grounding can cause multiple lighting issues and trigger false warnings. For more precise diagnosis, connect an OBD2 scanner to your vehicle's diagnostic port. The scanner will retrieve specific diagnostic trouble codes that pinpoint exactly which circuit or component has failed. Advanced scanners can monitor live data from light circuits, perform actuator tests to verify component operation, and clear diagnostic trouble codes after repairs are completed to reset the warning system. Here's a real example. A 2023 Ford F-150 Lightning showed persistent brake light warnings even though the lights worked perfectly. The root cause was software incompatibility with aftermarket LED bulbs. The solution required both a firmware update and switching to OEM-compatible LEDs. This example highlights a critical point. Always verify LED compatibility with your vehicle's monitoring system. Modern cars expect specific electrical characteristics from bulbs, and incompatible LEDs can trigger false warnings even when functioning properly.